So now we have a problem on the internal rate of return. And then first of all, you'll notice that this problem is kind of ambiguous. We're not given that whether C is an inflow or outflow or R is the inflow or outflow. But it doesn't really matter because at the end of the day, we're just going to put everything into one side of the equation and then let that equal to 0, and then we'll solve for I. So it's perfectly fine to assume that C is an inflow and that R is an outflow, or to assume that C is an outflow and R is an inflow. So we're going to go with the decision to treat C as an outflow. So C0 of 3000, that is minus 3000. And then at time 1, we get another outflow. So multiply that by V. And then R1, so this is, if we're treating this as an inflow, we're treating this as an outflow. So we get $2,000. So that happens in time 1. And then time 2, we get another inflow of $4,000. So we plus 4,000 V squared. And then the definition of a total rate of return is the interest rate I such that this entire equation is equal to 0. So if we solve this and we find I, that I is going to be the internal rate of return. So I'm just going to divide both sides by 1,000 to simplify things a bit. And then now in order to solve this, we have to factorize this term over here. So if you're familiar with factorization, you can always use the cross method, or you can always use your calculator program to figure this out. But you can use a cross method to factorize this, and you'll see that v is equal to -1. This is a rejected solution. This is pretty much impossible for any I that makes sense. And the other v is 3/4. So this is our answer, and the corresponding I to this can be found by flipping the fraction. So I is equal to 1/3. And since we're looking for an I that can be expressed as 1/n, our I is equal to 1/3. So if correspond to the I over 1/n, our n is going to be equal to 3. So this is our answer.